Hello again, it's Cliff here from Down Under. In this video I want to talk about ways that you can avoid having a crash with Rapidturn. Things that you can do to make it less likely that you'll ever have a horrendous prang up. Things that you can do to boost your confidence about using NC turning. Cheers. Okay, we're just going over this simple acetyl part. This is a nice job for Rapidturn. So I've got three tools. A high-speed steel turning tool with a scallop for chip breaking, a high-speed steel threading tool, and a 2mm parting tool. The tool's parking in the right position so I can project the stock the right amount. Just going over quickly the program. It's just produced by conversational programming. I'm only making a few score parts, so I don't need to worry about the cycle time. As long as it runs automatically, I can go into the other workshop and do other work while it's running. So it doesn't matter if it takes 2 minutes or 4 minutes. That's my theory anyway. I'm roughing down that small diameter in 2 stages so that the small diameter is being supported by the stock and not roughing the full length, which would be too fragile for taking big cuts. Rather than getting effective chip breaking, because it's such a small fragile part, I can't take heavy cuts to break the chip. I'm stuck with curling the chip and taking retract wiping passes to wipe the chips off, the rat's nest off the part. And I'll run it now, and if you look closely you can see those retract passes wiping the swarth off the part before it becomes too much of a problem. Okay, well, let's run another one, and I'll film it from end on now so that you can see the gang tooling in operation a bit better. you can see the very simple part with 3 tools and what's involved in producing it on a Rapidturn with gang tooling. And I've given you that background so that I can now talk about some tactics to avoid a crash. And if you're like me, when you were first looking at getting into NC turning, I was a bit wary because, you know, you've got chuck jaws spinning round and tools rapiding backwards and forwards, and it sounded like a scenario where you could have some pretty horrendous crashes. I mean, it's only got to happen once where you rapid into the chuck and you're going to cause some real damage. And I imagine there's quite a few people who are holding off on buying Rapidturn or an NC lathe, or you've bought Rapidturn but you're reluctant to do gang tooling and production machining. You're worried about a crash. And so I'd like to talk now about some tactics you can employ to reduce or virtually eliminate the chance of a crash. And then you can relax and enjoy using your NC turning facility. Okay, so one of the things is, okay, so we've just given an example of producing that part with using conversational programming and producing a basic bit of code. So now that we understand what that is, let's have a look at a couple of different things we can do. Let's say we've produced the code and we haven't yet run a part. We're about to run our first part. How can we be sure that it's not going to crash into the chuck? How can we be sure we're not going to rapid a tool into the side of the headstock? Well, one thing you can do is have a look at your displayed toolpath. So what's most likely to happen that will cause a crash is if you make a muck-up when you're setting up your tools. You know, when you're touching off your tools, you're entering a minus value instead of a plus value, or decimal points in the wrong place, or you've got your tools mixed up in some radical way. And what it ends up with is a rapid into the chuck, or something horrible like that. Now, if you look at your graphics here, you see this line? That line is where the chuck is. So let's click on that line. And that'll immediately take us to the code. Here we are at this line. And I've put this in deliberately so you can see it. But see this go to Z minus 60? That would be a massive crash into the chuck. So what we do is we look for that error before we run the part. And then we can remove that bit of code before we have a crash. So there should be no lines going into the area where the chuck is. That's the first thing you can do to greatly reduce the possibility of a crash. Okay, so I've just removed that bit of code now. So there's the graphics relating to the part. That's where the chuck is, and there's no lines going in that area. That's a good sign. That's the first thing you can do. Now let's run the part and I'll show you another thing you can do to reduce the chance of a crash. Okay, so you're about to run your first part and you're a bit worried. You're not too confident that it's safe to run. So we've got 3 tools: a turning tool, a threading tool, and a parting tool. Now what we can do is we can slow down our maximum velocity slider right down to a creep. And the machine will be making a lot of noise, so I won't be able to talk over it very easily. So I'll just explain now what I'm going to do. So it's the transition from one tool to the next. When you're rapiding out from the part, or when you're rapiding across in the Y to the next tool, that's when there's most likely to be a problem. Once you're underway on the tool path, you can speed it up and you'll probably be okay. When we come to the threading, you'll see that I can slow it right down even during the threading, and it won't lose its pitch. That's the great thing about this PathPilot Rapidturn system. You really can't go wrong by slowing down that maximum velocity slider. So I'll just run it now and see if you can see me slowing it down and speeding it up. Okay, here we go. Let's fire it up. Hopefully I've removed that error graphic, or it could be really nasty. So we're just bringing the slider open a little bit. So you get worried here and you slow it right down to a stop. Now we're going to shift over. So we've just slid the maximum velocity slider, that's the bottom slider, right down to 0. And we're just going to creep it along, making sure everything's clear. We've backed off in our G30 position and we're looking to check nothing's going to foul, everything's okay. Looks alright. And you can just slow right down. At this point, you're going to do the threading operation, and it's really slow. That seems okay. Now you can speed it up. So just slow it right down. It won't lose its position or go haywire. And so, okay, now we're coming across to departing. We're worried about the Z. Is it going to be too near the chuck? Is that going to be clear? And so you see, you can just slow down and speed up. It doesn't hurt Path Pilot or Rapidturn, and you won't lose your position. And just go at a speed that you're comfortable with. Now, once you've run it once, that's the great thing about NC lathes. It'll just keep repeating itself. It's not going to do anything haywire again. As long as the first part's fine, you're going to be okay. So in a nutshell, there's two things you can do to avoid a crash. Look for any lines, for any graphics in the area where the chuck is or your headstock is. Make sure that's clear. And then when you run the first part, use this bottom maximum velocity slider and just come on and off 0%. So you're just creeping from one part of the program to the next as you feel confident, as you can see the clearance. If you're not sure, take it to 0. It'll just stop, and then you can have a look at it from the left and the right and make sure that it's clear. If the worst comes to the worst and you're not happy, you really don't want to carry on, press feed hold, and then you can stop it and reset it. And at that point you can measure your chuck jaw and say, okay, I'm 1/4 of an inch away, I didn't need to worry. Reset, start again, come back to that point, carry on. So with this wonderful facility of the maximum velocity slider, feed hold, stop and reset, you can work your way through the program very hesitantly, even if you're a very cautious, nervous person, and run your first part without risk of a crash. Okay, so another thing you can do if you're really not sure about your program is to run the program a long way away from the chuck in fresh air. So I've done a video a few months ago on Rapidturn offsets, tool offsets, and remember that all the tool offsets are linked together in the tool table. So if you move the main DRO, see if I can show this graphically, the end of the tool is usually Z0. And we set it up on Z0. But if we move away, okay, so what I did here was I moved the Z 100 millimeters and clicked 0 so I could remember where it was. Now we can run the program in fresh air. And you can see we're running the program there in fresh air, and the other tools will all be linked to that relative position because we changed the main DRO and not the offsets in the tool table here. That's all remains the same, they've linked the same. So what we can do now then is go back to that T01, T0101. We've got back to that. We can wind back to that position we were in, that we had entered 0 on, find that 0, and enter the number that was in there, and we got the tool back to where it was. And that way we've checked the tool path in fresh air well away from the chuck. And we could do that in the Z, which is the longitudinal, or in the X, which is up above the chuck, or in whatever position where you think there's a big block of fresh air and you can run the tool path safely. If you do decide to use the fresh air machining method to check your tool path out, remember to set your G30, that's the tool park position, back beyond that temporary position temporarily. That's only an approximate position, but you don't want to have your tool rapidturning in towards the chuck during the tool park maneuver, and then you can put it back to about where it was when you finish testing it in fresh air. Alright, that wraps it up. Thanks for watching, guys.